Okay, now let's discuss about the quiz answers. Yeah. First, question number 1. The environment types on deciding what to order from a set of lunch menu include, of course, this is discrete. Yeah. Why? Because we just need to select. That's it. Our task is just to decide what to order. We already have the lunch menu, and then we just decide which one. Of course, this is discrete. Is it sequential? No, it's not sequential, yeah, because whatever you decide now doesn't mean anything for your future decisions like that. So this is not dynamic. No, it's not dynamic, it's static, because this is the very simple basic task that you need to perform. Just need to choose, yeah, decide from set of lunch menu. So this is static instead of dynamic. Single agent, because you don't really need other agents in this kind of situations. And it is deterministic. That's mean there is no chance. You don't involve any probability in this part. You simply just decide whatever you want to buy. Yeah. Okay. And then number 2, what does a rational agent do? So the answer is we can gather as much information as possible before making a decisions, yes, because an agent can see the surrounding and complete all the informations and put it inside their database, yeah. And then maximize the expected performance according to the agent's state or opinion. Yes, of course, it's true. The one that is false is some statement like this, yeah. Maximizing the expected performance, the true performance of the real world. Nah, that cannot be happen. Agent has their own mind, yeah, so they can decide whatever they think this is the best for them. Agent does the right thing given what it knows. So this is the definition of the rational. Yeah, being rational means that you do the right thing given what you know. Yeah. So the answer is all the answer is correct. Yeah. Okay. Okay, next. Question number 3. Okay. Oh, it's very small. I cannot see. Okay, I make it bigger now. Stop sharing. Okay, now given the adjacency list here, yeah, we have this one. The starting node is S, so this one, and then the goal node is B. S, and then you end up in B. B is here. This is the start, this is the end. Please show the expanded node based on the depth first search. Yeah, depth first search. So that's mean when you see S, yeah, okay, all the options begin with S. So you start with S. What after S? You go from the most left child, right? Let's check here. You have A, so you go to the A. SA, SA, SA. So this three, yeah, between these three. And then you go back one step up because there is no more node under this A. And then A is empty. We're done with this one. We're done with this one. And then they go back to S. S, what is the next node? Next node is C. So we go to C here, right? SAC, SAC. Okay, still we cannot eliminate one option here. After C, let's check the most left node, remember, yeah? So we go to E. After C, we go to E here. C is done. Now we see the option E here. AC, SACE is S. So now we have two options here because this is B. This is incorrect, right? E, what is after E? After E, the child of E is S. S, we already done this one, so we don't have to follow this path. Yeah, we go back to the C and check what is the next node after E. We need to see. Yeah. Okay, so the next node after E is B. So we go to B. We go to B. And this is our goal. That's mean the search stop here. S, A, C, E, B. So this one. Okay. Next questions. Annotate. Clear. Okay, now, which ones of the following statements are true? First, BFS is optimal if the path cost is a non-decreasing function. Yes, this is true because they always optimal if, only if, the cost between node to the other node is the same. 1, 1, 1. That's mean the same cost because they don't want to check. Yeah, BFS never check and never consider the cost between the node. Yeah. And we can say this is optimal. Non-decreasing mean like this. Constant. BFS is optimal when all the action the same. Yeah. These two sentence means the same. UCS involves the use of heuristic. Do you think so? No, yeah, because uniform cost search still belong to the family of uninformed search. Yeah, week 2, remember. Uninformed search doesn't use any heuristic, but they use the real cost in here. DFS expands the shallowest node in the frontier of the search tree. Do you think it's correct? The shallowest, no. From the name, we can see that this is the deepest. Yeah, we want to explore the deepest node first. So this is not correct. And then DFS is not optimal. This is true because the one that optimal is BFS. Okay. Okay, next up. Number 5, which search method will expand the node that looks closest to the goal? This is very easy, straightforward. So that's why we call this greedy because it looks faster, and whatever looks closer to the goal, they pick that action, they pick that node. So the answer is greedy. Uniform cost search, no, uniform cost search doesn't count any heuristic, so you cannot say anything. Breadth first also don't use any heuristic functions. A star consider really carefully the heuristic plus the real cost. Yeah, so with the question like this, the answer is greedy. All right, so number 6, given the tree in the picture, the start node is A, and the only goal node is G. So this one. This is the goal, this is the start. Okay, now we follow the same symbol, right? The G is the cost of the path so far, H is the estimate, F is the total path cost. Yeah, so F equals to G plus H. Okay, by using the question is uniform cost search, yeah, UCS. The expanded node R, that's easy. UCS doesn't use any heuristic, remember? So they use the G only. Yeah, so A to which one? The closest, 25 or 80? Of course, it is C. Yeah, because the cost is smaller in here. So AC, we have AC, AC. So we have 3 options, right? AC, AC, AC. And then what next after C? We still have 80 in here. We have, when we explore C, we have the successor 5 and 45 and 80. Which one do you think is the closer? Which one do you think the cost is smaller? Of course, this one, F, right? So we visit F because 5 is smaller than this 3. So ACF, ACD, ACB, ACF, of course, this one. What next is G. So because this is the first, the smallest cost, and then go to the next smallest cost is G, and we found the goal straight away. So the answer is A, C, F, G. Next, number 7. Okay, given the search, by using, now we're using greedy best first search, okay? What happened with greedy is it looks closer to the goal. Yeah, they already use the heuristic in here. So we have A and our goal still G. Now it looks closer. That's mean you see this number. Yeah, this number, heuristic only. 30 or 55. Of course, we pick 30. Yeah. So AB. That's it. That's simple. Nothing else. Yeah. Only this one option give you A and B. See, pretty straightforward. So this is the correct answers. If you want to continue to traversing this tray, so we have B, H equals to 30, and then in your fringe you have C with H equal to 55. Now, because you already visited the B node, now you have this one, 35 and 20. 20, 35, and 55. Which one do you want to choose? Of course, the closer is this one, A. Now you already done this one. They don't have any successors. So you left with these two options, 35 and 55. So you go to D. Now you don't have any more options. Now you need to visit C. Right? After you visit C, you can check 80 or 0. Of course, we pick 0. And this is your goal. That's it. So this is the correct options. Number 8. This is pretty straightforward. Select all that apply. A zero-sum game is a situation in which one group can win something only by causing another group to lose it. Or a situation in which each participant's gain or loss of utility is exactly balanced. Yeah, same, yeah. Gain or loss. Situation where everyone can gain or win-win game. No, of course, this is not the correct answers. Why? Because it's a zero sum. Yeah, all of the above are correct. Of course, this is wrong. Which ones of the following are correct? First, both classifications and regression are supervised learning problem. Yeah, because they both have label. Yeah, label data. Classifications is for discrete. Regression is for continuous. This one, supervised learning use real-time input data. Is it correct? No, because they always use the historical data because we need the human label data, right? This is incorrect. There is no complete and clean labeled data set in unsupervised learning. Okay, yes, this is correct because they say labeled. There is no labeled data sets. This is true. In unsupervised learning, the machine is given training based on unlabeled data without any guidance. Yes, this is clear, yeah? Unsupervised meaning that we don't have any guidance. Number 10, for different centroid initializations, the k-means algorithm will definitely give the same clustering result. No, no, yeah. Every time you initialize with different centroid, they can have the different assignment, cluster assignment. Okay, so minimax. Minimax is easy. What is the best move for max? So this is max, min, and max. So let's start from the max here. We pick 6. We pick 8 because this is maximizing value. 8. This is 8. This is 9. This is 7. This is 4. This is 9. Now move up one layer, one level. We have min. So this is 6. This is 8. This is 4. And then move up again. You have the maximum again. This is 8. So the best move is this one or this one. So you come up with B, yeah? The step, middle step, B. Now, number 12. Which value is assigned to alpha and beta in the alpha-beta pruning? Alpha equals to max and beta equals to min. So these two correct, but there is the more correct answer, which is this one. Which one of the following is finally produced by a hierarchical clustering? A dendrogram, yeah, we already discussed this. Dendrogram showing how close data points is. All the answer are correct? No. Final estimation of cluster centroid? Nope. Number of cluster? No. We come up with the dendrogram. To which depth does the alpha beta pruning can be applied? All level, yeah. There is no limitation in these situations. So you can apply alpha beta pruning to any depth level. Number 15, a frequent item set in a priori is, select all that apply. A group of item or item set appearing in at least min sup transactions. At least, yeah, so you can have more. Yes, it's correct. A group of items whose support is greater than some user-specified minimum support. It's the same, yeah? The same, similar definitions. An item whose support value is less than a threshold, of course, no. We don't want something less than a threshold. All of the answers are correct, no. Okay, now about the last questions. Let's draw the tree. This is S. S. For example, okay, look at the order. Yeah, you go to the right first and then go to the left. So this is A, this is B. A, and then this is B. Okay. You go to the right first. B, this is C. You have to branch the branches D, C, D. You go to the right first and then up. So you have C, you have D. B also have two children here. B is going to the left first and then up first and then left, yeah. E and then this is F. E and then F. Okay. What next is what is after C? G. H. Okay, I skip G because G is the goal, so you don't get confused. I'm using H and I. Okay. After C, we have H. We have H. Here we have I. Also, we have I. Okay. J, K, J, J, K, K. We have L, L, L. We have M. And then what after L, M, N? We have N. We have N. O. And then we have P. After O, we have Q. And then we have R. After P, we have R. We have R. Q also, we meet in one same note. We have R. What after R? We have two branches, right? From A, R has two branches, R, Q, and S. Check again. Q is to the left, so you go down first S. And then you go to the Q. R also the same. S and then Q. How about R from B? Set. Okay. Now check the order. Which one goes first? Down or right? So you go down first. So you have S. You have B. Same here. You have S. You also have B. Yeah. From A, we arrive in S. One more note, and this is your goal. Okay, let's check. How many? Including, yeah, inclusive. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 35, 36, 37, and then 38, 39, 40. So 40 notes. So that's the hard way. Yeah, if you want to do it quick, just see like this. You can do something like this. From S to G, how many paths are there? Yeah, 1, 2, 3. So we basically have 4 paths, which is this one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The other one is like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then the other one is using this way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then the other one is like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if you want to estimate, yeah, that's very easy. So you can say it's 10 times 4 because you have 4 different paths to go to this G. Breadth first search, always search all the possibility. So your answer will be 40. That's it. Good luck for your exam. If you have any questions, just contact me. Okay, bye-bye.